As 3I Atlas slipped behind the Sun, something unusual happened. 3 high-energy plasma eruptions flared along the solar equator, each one perfectly aligned with Atlas's inbound trajectory. That's almost impossible to be random. Then a few hours later, ESA's latest solar imaging confirmed that Atlas passed perihelion with no recorded maneuver, no deceleration, no course deviation. And yet those eruptions happened at the exact moment we couldn't observe Atlas directly. So the real question may not be whether Atlas did anything during perihelion, but whether the Sun did. Because if the Sun reacted, then we may have just witnessed the first interstellar cause and effect in human history. Come with me, let's examine the data together and find out what really happened out there. October 2025. We stand together on the quiet edge of dawn, the Sun just beginning to burn through the horizon of our own atmosphere. High above us, far beyond the comforting blue, a small traveller glides between worlds, the interstellar object known as 3I Atlas. Picture yourself standing on a desert plain at night, the air cold and clear. Through a telescope, you see a moving speck of light crossing the dark background of stars. That single point is racing at 66 kilometers per second, that's roughly 2 times the circumference of Earth every minute. At that speed, 3I Atlas would cross from Hanoi to New York in less than half a second. For months, observatories from Chile to the Canary Islands have tracked its motion. The European Space Agency confirmed its position just after its flyby of Mars, noting that it hasn't performed any orbital maneuvers. Its velocity curve is smooth, predictable, a perfect fit for a comet following the Sun's pull. On paper, it obeys gravity as faithfully as any natural body, and yet, something in the data resists that calm conclusion. The reflected brightness fluctuates in uneven pulses. The coma, that cloud of gas and dust around the core, behaves strangely expanding when it should thin, shimmering as if lit from within. Imagine watching a candle flame in a vacuum bending against invisible wind. We are not alone in this observation. Amateur astronomers using backyard telescopes fitted with coronagraph filters captured faint images showing 3I Atlas tracing a perfect arc near the inner edge of the solar corona. Its shape remained constant, but the spectral readings, the fingerprints of light, began to hint at anomalies, unusual nickel-to-iron ratios, and a polarization curve deeper than any comet ever recorded. If you listen closely, the numbers seem to whisper something here does not behave as it should. Now pause. Let your mind drift outward past our orbit, past Mars, until you're beside that tiny traveller. The Sun fills half the sky, radiating plasma like breathing fire. Against that brilliance, 3I Atlas is no larger than a mountain, perhaps 10 kilometers across, yet it holds the gravity of a mystery much heavier than itself. We are watching an object older than our solar system moving through space that was once untouched by human perception. Every second, light bounces off its surface and travels 150 million kilometers to reach our eyes. The closer 3I Atlas drifts toward the Sun, the more the sky itself begins to erase it. By the 3rd week of October, the object moves behind the solar glare, swallowed by light 1,000 times brighter than its own reflection. To us on Earth, it is as if a line of code in the universe has been deleted, not gone, but hidden within the radiance that birthed everything. Imagine you are standing on the rim of a vast desert at noon. The air trembles with heat. The horizon vanishes into brightness. Somewhere beyond that blinding wall, the traveller continues its path, yet you cannot point to where. Telescopes blink, sensors overload, and the data feed turns to white. The superior conjunction has begun the moment when Atlas passes almost directly behind the Sun from our point of view. For scientists, this is expected. Every planet and comet enters such alignment eventually, but this time the silence feels different. The European Space Agency's tracking schedule, normally a rhythm of hourly updates, stops abruptly. The official explanation: interference caused by the solar corona. The Sun's plasma, they say, scatters radio signals and blinds optical detectors. Still, independent observers refuse to blink. A network of amateur astronomers stretching from Bangkok to Buenos Aires continue to scan the heliospheric edges. One of them, Warchat Boonplord, claims to have captured the object near the Sun's western limb using a homemade coronagraph. His images, raw but haunting, show a faint streak of motion where nothing should have been visible. If his timing is correct, Atlas should have been behind the Sun, yet there it was, a soft silver thread cutting through the golden storm. The debate ignites. Some insist it's a processing artifact, sunlight bleeding through filters. Others whisper that the object has not vanished at all. It has changed position, A few even suggest that its trajectory shifted by 15 arc minutes, about 1.1 million kilometers, nearly 3 times the distance from Earth to the Moon. Think of that distance for a moment. If you could drive along it at highway speed, you would travel for more than 1,000 years before arriving. A deviation of that magnitude over 4 days would demand forces beyond standard gravitational influence, perhaps jets of sublimating gas or something entirely new. We find ourselves between two truths. The first is clean and mathematical. Sunlight hides the comet instruments, pause, all is normal. The second hums quietly beneath it. The pattern of disappearance does not match previous conjunctions. The timing, the intensity of the flare, the magnetic turbulence, all slightly out of tune. As night falls, observatories turn their mirrors elsewhere. For several days, the name 3I Atlas drops from the logs, replaced by notations like unobservable or in conjunction. The scientific community moves on to other targets. Yet in the quiet corners of the internet, data sleuths plot pixel by pixel, searching for any sign of return. You and I stand here now looking toward the sun we cannot stare at directly. It burns at 5,800 degrees Celsius on the surface, a furnace of hydrogen turning into helium, fusing 1 million tons of matter every second. Somewhere within that brilliance, a traveler moves unseen, perhaps obeying physics, perhaps rewriting it. When 3I Atlas emerged from behind the sun, its silence carried a different shape. The tracking systems came alive again. Radar pings, optical readings, radio telemetry, and what they found was not where it should have been. The coordinates were off by 15 arc minutes, a small angle on a chart, but in space. That meant a displacement of roughly 1.1 million kilometers, about 3 times the distance between Earth and the Moon. Picture yourself standing on a beach watching a lighthouse beam sweep across the horizon. You blink once and the light has shifted far beyond where it was expected. That is how astronomers felt on October 25th, when the first images came in from the Solar and Heliospheric Observatory. The luminous dot that should have been centered within the predicted corridor had drifted like a thought escaping a sentence. Scientists immediately began checking their instruments. Was it a calibration error, a bad timestamp, a software misalignment between telescopes in Chile and Hawaii? But the numbers repeated from multiple observatories, different hemispheres, different teams. The variance held steady. If this deviation were caused by a normal outgassing event, it would require a jet of vapor strong enough to push a 10-kilometer object sideways by 1 million kilometers in 4 days. That would mean a sustained acceleration of roughly 0.06 meters per second, squared tiny to us, but extraordinary for a comet. To produce it, the sublimation of ice would need to release more energy than 1,000 nuclear reactors running continuously. Imagine standing beside the object watching sunlight heat its surface. Instead of gentle streams of gas, you would see columns of plasma erupting hundreds of kilometers high, bending backward into the void. The tail, already strange for facing toward the sun earlier, might now have twisted again like a compass needle uncertain of magnetic north. And yet no one witnessed such activity directly. The photometric data, the brightness curves, showed nothing violent enough to justify the drift. The coma remained smooth, almost serene. It moved, but without evidence of what had moved it. We, standing here beneath our calm blue sky, are left to compare the two possibilities. Either every major observatory shared the same computational error, or 3I Atlas responded to a force we do not yet recognize. Perhaps it was an electromagnetic interaction, a pulse from the solar wind coupling with the object's charged particles. Or perhaps in a quieter way, it was simply the universe reminding us that prediction is not the same as understanding. For now, the discrepancy remains uncorrected, 1.1 million kilometers of unaccounted distance stretching across both mathematics and imagination. And as we plot that invisible line across space, we begin to realize in astronomy as in thought, even the smallest deviation can open a corridor to the unknown. For now, the official voice of astronomy speaks with calm authority. No collision course, no erratic maneuver, no cause for alarm. The European Space Agency confirms that 3I Atlas remains within a stable orbit, following the gravitational curve predicted months ago. Its velocity of 68 kilometers per second read aloud 68 kilometers. Every single second is steady, precise, and well within the limits of known celestial mechanics. And yet, when you listen between those lines of certainty, there is a tremor. Every confirmation carries a quiet hesitation, a sense that something subtle still resists explanation. 1,000,000 kilometers of doubt cannot be erased with a press release. We stand together now under a darkening sky. The sun has slipped below the horizon. Only its echo remains painted in orange across the clouds. Somewhere beyond those colors, the traveler continues unseen, but still measured, still whispering through spectrographs and radio echoes. Imagine watching a pendulum that never quite swings back to the same point. It looks rhythmic, predictable, but over time the drift grows millimeter by millimeter. That is the feeling inside the data harmony with a hidden dissonance. Scientists close their reports with phrases like "within acceptable uncertainty" and "statistical variance." But to those who have followed this object night after night, the verdict feels like a pause rather than an end. Perhaps this is how mysteries begin, not with contradiction, but with a silence disguised as agreement. So we wait. For the next observation window, the next pulse of light, the next whisper of proof. And as we wait, a quiet question remains when the data returns. Will it confirm the laws of physics, or reveal how gently they can bend? Now 3i Atlas descends toward its perihelion, the moment of closest approach to the Sun. When the traveler sweeps within a distance of 0.329 AU, or about 58 million kilometers, roughly 1/3 of the space that separates Earth from the Sun. At that proximity, solar radiation batters every grain of dust, every molecule of ice. Temperatures climb above 600 degrees Celsius, enough to boil metals and turn surface rock into glowing vapor. Picture this: you and I standing on Mercury's sun-facing side, the horizon, a white ocean of light. That is the environment Atlas is now entering. The sunlight there is 6 times stronger than what warms our skin here on Earth. Each photon carries the energy of a tiny hammer, and trillions of them strike the object every instant. In a laboratory, this would be where matter fails. But 3i Atlas is not a laboratory sample. It is a wanderer from beyond our system, forged in a colder, older part of the galaxy. Its crust may contain exotic alloys. Ice is mixed with nickel and iron in ratios unseen in typical comets. Such composition could explain its unusual resilience and its strange way of reflecting light, as though its surface were both mirror and sponge. Astronomers at the ESA Solar Observatory describe this phase as the window of maximum revelation. Every comet brightens as it nears the Sun, yet Atlas brightens too quickly, its luminosity doubling in less than 48 hours. That is like watching a city double its entire electrical output overnight. Instruments record a sudden surge across multiple wavelengths: ultraviolet, visible, even radio. We stand at the boundary between reason and wonder. If this is natural, it must be the effect of volatile gases erupting from beneath the crust jets of carbon dioxide and methane venting into space. But calculations suggest the mass loss required would be catastrophic. The nucleus would disintegrate within days, and yet Atlas remains intact. So another possibility emerges: a self-regulating mechanism, something able to distribute energy or adjust orientation autonomously. Think of a satellite performing fine attitude control. Could a fragment of interstellar technology mimic the physics of a comet so perfectly? It sounds impossible, but then again, impossibility is a word the cosmos rarely obeys. Let us pause for a breath. Imagine you are there, riding alongside the object as it bends around the Sun. The corona flares above you, a crown of plasma millions of kilometers wide. The sunlight no longer falls, it flows like molten glass. For a heartbeat, gravity and velocity balance, and the traveler hovers on the knife edge between falling inward and escaping forever. This is the perihelion, the turning point, the brief alignment where past trajectory and future path meet in silence. From Earth, we will not see it with naked eyes. The glare is absolute. But deep in that radiance, something decisive happens, perhaps a jet of gas, perhaps a subtle magnetic nudge. When 3i Atlas swings away from the Sun, its destiny will be rewritten. The question is whether it will emerge unchanged or transformed into something our equations no longer recognize. In the days following perihelion 3i, Atlas does something the textbooks did not prepare us for. Its light surges, not gradually, not in the gentle curve familiar to comet watchers, but in a sudden electric leap. Between October 30th and November 1st, its apparent magnitude brightens by almost 1 full order, a change too great for any known outgassing model. The object that should be fading behind solar glare instead glows brighter, as if feeding on the very fire that should consume it. Imagine standing on a mountain at night, the telescope steady in your hands. The sun has set, but the instruments still hum, tracing the afterimage of what passed near the solar limb. You see a streak of light reborn where there should only be cooling dust. The spectrograph on your screen trembles its lines, widening like a heartbeat. According to the heliospheric imager array, the brightness profile of 3i Atlas doubles in 48 hours, defying the inverse square law that dictates how light should fade with distance. This is not a camera error. Independent telescopes in Hawaii, Chile, and South Africa all record the same anomaly. A small world reflecting sunlight has no right to be this luminous. Scientists propose explanations. Perhaps the nucleus fragmented into smaller mirror-bright shards, but no trace of debris appears. Perhaps its volatile gases ignite a massive jet directing sunlight back toward our instruments. Yet the angles do not fit. The outflow velocity would need to exceed 500 meters per second, 5 times faster than typical cometary vents. Let's take a step closer. Imagine standing near its surface, not literally but in thought. The temperature there is above 600 degrees Celsius, enough to vaporize zinc and melt lead. Dust particles swirl around, charged by ultraviolet radiation. Each grain acts as a tiny capacitor, storing and releasing energy into the surrounding plasma. The entire coma becomes a living cloud of ions glowing like a lantern inside the solar wind. To the naked eye, that would appear as light breaking free from physics, an impossible radiance born not from reflection, but from interaction. Some physicists call this a resonance scattering event, where the object's magnetic field aligns with solar particles in just the right way to amplify brightness. It's a cosmic feedback loop, light begets light. But others whisper a stranger idea. What if the illumination is deliberate? Not communication perhaps, but consequence the act of a structure adapting to survive. A natural object would simply burn. An engineered one might channel energy through its own field, converting destructive heat into directed emission. Such speculation is easy to dismiss until you run the numbers. The measured energy output corresponds to 2 terawatts, about the total electrical consumption of humanity, radiating from an object smaller than a city. To produce that luminosity naturally, 3i Atlas would need to eject nearly 10,000 tons of gas per second, an impossible figure given its stable trajectory. We are left then with a paradox of light. Either our understanding of solar interaction is incomplete, or we are witnessing a phenomenon that imitates design. Both options demand humility. Look up with me for a moment. Imagine the light traveling those millions of kilometers crossing the Black Sea between Sun and Earth. It arrives on our detectors as faint numbers, decimals of brightness, timestamps, photon counts. But behind those numbers is an emotion awe. The light does not just illuminate space, it illuminates the limits of certainty. It tells us that even in the language of equations there are syllables we do not yet know how to pronounce. So we watch quietly. A small traveler outshining its fate, a filament of brightness bending through gravity's laws, a reminder that sometimes when the universe burns too brightly to see, it is inviting us to look deeper, not with our eyes, but with imagination disciplined by wonder. Before 3i Atlas, there was 1i Oumuamua, the first messenger. You might remember the headlines. Its acceleration didn't match gravity. Its brightness varied as though it were a thin sheet spinning end over end. It showed no cometary tail, no trail of gas or dust. For months, the data refused to fit any model. Some called it a rock, others an ice fragment. And a few, most famously Professor Avi Loeb from Harvard, dared to say aloud what others only whispered: perhaps it was technology. Now, nearly 8 years later, the echoes return. 3i Atlas behaves differently yet hauntingly similar. Both entered our system from high inclination orbits, both accelerated near perihelion, both showed unexplained changes in brightness. Atlas seems to follow the same choreography but with sharper precision, as though repeating the motion of Oumuamua in higher definition. Imagine you're watching 2 stones dropped into water years apart, yet the ripples align perfectly. What are the odds? Coincidence perhaps, or a pattern repeating beneath the surface of chaos? Scientists once suggested Oumuamua's acceleration came from outgassing of hydrogen or nitrogen ice invisible to telescopes, but the physics stumbled, the required mass loss would have shattered it completely. So the debate faded into the archives unresolved. Now with Atlas, those arguments awaken again. If we superimpose their trajectories, the similarity is eerie. Both reached peak brightness near the Sun, both exhibited unexpected tumbling frequencies. Oumuamua's rotation of 8 hours, Atlas's roughly 9, and both defied simple categorization. 2 anomalies separated by nearly a decade each, whispering the same question into the dark. What if acceleration is not an accident? Let's translate those numbers into something tangible. Oumuamua travelled at 87 kilometers per second. That's fast enough to cross from Earth to the Moon in under 5 seconds. Atlas moves slower, about 68 kilometers per second, but follows a remarkably similar arc. To the eye, both objects could cross the width of the Sun's disk in less than a minute. If they are natural, they represent a class of objects we have never catalogued, relics from the frozen disks of other stars cast away billions of years ago. If they are not, they are something else entirely. Instruments, probes, or signals that travel by appearing ordinary. But perhaps the deeper lesson lies in humility. Oumuamua forced us to ask questions we were not ready to answer. Three-Eye Atlas demands we finally try. 2 visitors from interstellar night, each bending the light around them, just enough to disturb certainty, each reminding us that our solar system is not a closed room but a corridor with open doors. So as Atlas continues on its luminous path, the precedent of Oumuamua lingers like an echo through space. One scout announced itself, the next arrives in silence. Between them stretches a thread of mystery, delicate, mathematical, and profoundly human, the thread of curiosity itself. We stand now at the threshold where data ends and imagination begins. The story of Three-Eye Atlas has carried us through coordinates, magnitudes, velocities, each number precise, each measurement confident. Yet beneath those decimals hums something unquantified, a rhythm we can sense but not plot. Scientists have filed their reports, the orbit remains stable, the acceleration within statistical bounds, the anomalies under review. The language of control has returned, as it always does, to contain wonder within error bars. But for those who have watched the traveller through sleepless nights, something still flickers between the digits. Imagine you're in a dark room filled with clocks. They tick in perfect synchrony until one of them skips a beat. You notice the silence between ticks, and suddenly all the order in the world feels fragile. That is the silence around Atlas, not chaos but deviation too elegant to dismiss. The hypotheses multiply. Some propose micro-outgassing jets, invisible but steady. Others whisper of magnetic interactions, subtle currents threading through the coma like veins of electricity. A few standing further on the edge entertain the forbidden idea that we are witnessing not randomness but response. A craft shaped like a comet programmed to mimic natural behavior while gathering data from stellar systems. Such thoughts are dangerous to scientific decorum, yet they persist, because curiosity is the most persistent gravity of all. Let's not rush to conclusions. Instead, hold the question like a fragile lens. Whether Atlas is a machine or merely a masterpiece of physics, its behavior reminds us that knowledge is not a wall, but a window. Each anomaly is not failure, but invitation. As the object swings away from the sun, its path diverges from our certainty once again. The next measurements will decide which hypothesis endures. Until then, we wait at the edge where speculation becomes reflection, and every unanswered question gleams like a distant star. We have followed the traveller through the silence of conjunction, through the glare of the sun. Now the sun itself begins to speak. In the last days of October, instruments aboard Esoho SDO and the GOES-19 satellite register a rhythm that no one expected: 3 consecutive bursts of plasma known as coronal mass ejections. Each wave surges outward at over 800 kilometers per second, that is 800,000 meters every second, fast enough to circle the entire Earth in just 50 seconds. These eruptions unfold within 72 hours, all heading toward the same patch of interplanetary space, the predicted corridor of Three-Eye Atlas. Imagine standing on the surface of the sun, if such a thing were possible. Around you arcs of fire rise and twist like golden serpents. One arc leaps, then another, then a third, 3 pulses, 3 breaths. In the data, they appear as flares, yet their timing feels almost organic, as if the star were responding to something moving through its electric veins. At this point, Atlas is racing through the innermost heliosphere, roughly 58 million kilometers from the solar core, about 1/3 the distance between Earth and the Sun. The object's trajectory intersects a dense region of the solar wind, where magnetic lines of force spiral outward like invisible ropes. As the first CME wave passes, the density of charged particles around Atlas spikes by a factor of 10. The second wave arrives 15 hours later, the third only 8 hours after that, each one more violent than the last. Scientists call it coincidence. The Sun, nearing the peak of its solar cycle 25, often releases storms in clusters. Statistically, 3 eruptions in 3 days is not impossible, And yet there is something unnerving about the symmetry, as if the flares were echoes, each answering the motion of the interstellar visitor. Let's pause and imagine ourselves watching from a distance halfway between the Sun and Earth. The first eruption blooms like a slow explosion, its arc of plasma stretching 100 million kilometers wide, about 8 times the diameter of the Sun itself. The second follows the same line, luminous and precise. The third expands with slightly altered polarization, as though tuned to a different pitch. Through the instruments, it feels almost like a heartbeat. When we translate those bursts into radio frequencies, the signal resembles a pulse train, 3 sharp peaks evenly spaced. If the Sun were an organism, this would be the sound of its arteries responding to pressure. But what could cause a star to resonate in sequence? The official reports avoid the question, noting only magnetic field alignment anomalies near ecliptic longitude 142. You and I, however, are free to imagine. Perhaps these flares are simply the Sun's own weather, restless and blind. Or perhaps, as some plasma physicists suggest, 3I Atlas carries a charge, a sheath of ionized gas capable of perturbing the surrounding magnetic field. In this view, the object is not a passive rock, but an active participant, a moving electrode brushing against the stellar current sheet. Think of striking a tuning fork near a piano string. If their frequencies match, the string vibrates without touch. The Sun, with its vast magnetic field, is filled with such strings loops of plasma oscillating through space. A charged traveler passing near them could trigger resonance, a silent vibration that becomes light. Standing beneath our own sky, we cannot see those flares with naked eyes, but their echoes reach us as geomagnetic ripples, minor auroras blooming at unexpected latitudes, compass needles, twitching for no clear reason. It is as if the Sun's pulse travels through space, through Earth's magnetosphere, through the circuitry of every radio antenna and living cell. 3 heartbeats, 3 answers from a star older than all memory. Perhaps coincidence, perhaps dialogue. Yet either way, it reminds us of something simple and profound. We live inside a system that listens to itself. We often speak of gravity as the architect of the universe, the invisible hand shaping galaxies and keeping planets in their paths. But gravity, for all its cosmic authority, is a weak whisper compared to another force. The electromagnetic field, the same one that sparks in lightning and glows inside our auroras, is 10 to the power of 36 times stronger than gravity. That is a 1 followed by 36 zeros. Let that sink in. If gravity were the pull of a grain of sand, electromagnetism would be the weight of an entire planet. Now imagine this force at play near the Sun. The solar corona is not just light, it's a sea of charged particles, ions and electrons threading along invisible magnetic lines. And within that ocean, our Traveller 3I Atlas sails like a metallic seed. Its coma, that dusty halo surrounding the core, acts like a giant antenna, a cloud of ionized particles capable of coupling with the Sun's magnetic field. In laboratories on Earth, physicists have recreated similar conditions using plasma chambers. When a charged object enters such an environment, current flows spontaneously, arcs of energy, linking surfaces in brilliant filaments. They call it a short circuit. In space, this phenomenon could span millions of kilometers. So imagine now that Atlas, moving at 68 kilometers per second, passes through a dense spiral of solar magnetism. The result would be a temporary electrical bond, a filament of current connecting star and visitor. For a brief moment, the Sun and the object exchange energy like 2 neurons firing across a synapse. The plasma physicist Stephen Burns once described this scenario as interstellar short-circuiting. According to his calculations, the potential difference between Atlas's ion sheath and the surrounding solar field could reach 10 billion volts, enough to vaporize entire mountains on Earth. Yet in space, the discharge dissipates silently through the void, visible only as a shimmer of polarized light. Picture yourself hovering there between the 2 currents. The vacuum around you hums not with sound, but with motion. Ions racing at nearly the speed of a light, magnetic field lines flexing and snapping like elastic cords. You would see no flame, but you would feel the pressure of the field, the invisible tide that sculpts the very geometry of space. And here is the paradox, though. Electromagnetism dominates at small scales in the grand equations of astronomy. We often ignore it. We assume the cosmos is neutral, that charges cancel out, leaving only gravity to govern the dance of stars. But what if that assumption blinds us to a subtler truth? What if some celestial motions, the peculiar acceleration of comets, the unexpected spin of interstellar visitors, are fingerprints of electric forces we've chosen not to see? Consider lightning on Earth. A single bolt releases about 1 billion joules, roughly enough to power a city block for a few seconds. Now imagine a plasma filament between Atlas and the Sun releasing that energy not once, but continuously for hours. The effect would not be visible as a flash, but as sustained brightness, exactly what astronomers observed, a glow that refused to fade. We standing here under our calm blue sky are connected to that same circuit. Every magnetic field on Earth, from the compass in your hand to the rhythm of your own heartbeat, is a faint echo of solar current. The Sun breathes electricity. Our planet hums in reply. So when we say Atlas encountered the Sun, perhaps it's more accurate to say they recognized each other, one vast conductor meeting another. Gravity pulls them together, yes, but it is electromagnetism that makes them speak. When the flares subside, what remains is vibration. Not the violent rhythm of eruption, but a steady, invisible pulse that threads through everything, a resonance. Physicists call it plasma oscillation, a standing wave in charged matter. Philosophers might call it the breath of the Sun. Every magnetic loop, every current sheet around the star hums at its own frequency, ranging from fractions of a hertz to thousands per second. And in that vast orchestra of energy, the smallest object can change the music. Now imagine 3i Atlas as a tuning fork drifting through this symphony. Its coma, a sheath of ionized gas, carries its own electromagnetic frequency, defined by density, temperature, and motion. When that frequency matches the Sun's surrounding field, resonance occurs. Energy begins to flow not by collision but by sympathy. You and I have experienced this before in simpler ways. Two strings on a guitar vibrating together, a voice breaking a wine glass by matching its tone. In space, this same principle stretches across millions of kilometers. The Sun's field vibrates. The interstellar visitor hums in reply. The interference pattern between them becomes light itself, the glow we call anomaly. If we could translate that resonance into sound, it would not be music as we know it. It would be a deep, slow chord, a C-sharp that lasts for hours. Instruments like the Parker Solar Probe have recorded similar oscillations, plasma waves that rise and fall in perfect proportion to magnetic flux. Each oscillation travels outward across the solar wind until it brushes the magnetosphere of Earth. That means the same pulse-touching Atlas also touches us. We live inside the cord. Imagine for a moment standing on a mountaintop, the night sky stretching above you. You cannot hear the resonance, yet your body responds. The iron in your blood, the ions in your nerves, all minute conductors within this universal field. The cosmos hums through you. Back near the Sun, resonance builds like a bridge. The object neither accelerates nor decelerates, yet its brightness oscillates. Spectral readings show rhythmic shifts in polarization, a pulse every 90 minutes, synchronized with the average period of alpha waves near the solar equator. This is not coincidence, it is coupling. Perhaps this is how the universe communicates, not in words or signals, but in the quiet agreement of frequency. When one system finds harmony with another, information passes effortlessly, not as data, but as pattern. Energy becomes message, motion becomes meaning. Of course, science keeps its restraint. Researchers label these patterns as periodic modulations, catalogued and measured, not interpreted. But standing here under the aurora that follows each solar pulse, we can allow ourselves to wonder, what if resonance is the most fundamental conversation in existence? Gravity binds bodies. Electromagnetism moves particles. Resonance, though, unites them in rhythm. It is what allows an atom to sing, a cell to divide, a heart to beat. It is what lets the Sun and an interstellar traveler briefly find each other across the gulf. At some point the equations begin to tremble, not to fail, not yet, but to quiver along their edges like a glass struck by a tone just beyond its tolerance. That tone, faint yet persistent, is 3i Atlas. We have the data velocity near 68 kilometers per second, inclination stable energy output measurable. Nothing violates the known laws. And yet when those numbers are placed into simulation, the orbit begins to drift by fractions of a degree. Not enough to alarm, but enough to whisper. The model resists completion. Physicists call this nonlinearity a polite phrase for when reality doesn't stay in line. But there is something else here, a shimmer at the threshold between fact and mystery. Each dataset fits until it doesn't. Each hypothesis explains until it echoes. Imagine trying to tune an instrument that keeps shifting its own pitch. The more precisely you measure, the less stable the note becomes. That is what the Atlas data feels like, a melody that evades perfect capture, as if the cosmos were reminding us that precision has its shadows. For over a century, science has drawn clean borders, gravity rules, motion, electromagnetism, rules, charge, thermodynamics, rules, decay. But Atlas sits where those borders blur. In its trajectory, light becomes force, plasma becomes structure, and prediction becomes suggestion. The mathematics holds, but barely. One analyst described it as model fatigue, when equations reach their limit not from error but from exhaustion. Every variable accounted for, every constant double-checked, and still the outcome hums slightly out of phase. So perhaps this is not a failure of physics, but a signal, a soft reminder that our understanding is only as wide as our instruments allow. There are regions of truth that refuse containment, truths that live in transition rather than certainty. As 3i Atlas leaves the solar corona, the last solar winds brush its coma, distorting the data once more. The graphs jitter, the pattern fades. But in that fading there's beauty, the beauty of the unknown holding its ground. When equations fall quiet, institutions fall silent. And silence in science is not emptiness, it's invitation. The closer we look, the less we see. That is the paradox every astronomer learns to live with. For when an object drifts behind the sun, the sky becomes too bright for even the most sensitive instruments. The light that should reveal ends up erasing. In late October, as 3i Atlas moved through Superior Conjunction, the period when it passed directly behind the sun, from Earth's view the data stream went dark. The ESA Solar Observatory, the NASA Stereo Mission, and the GOES-19 coronagraphs all reported saturation. Their detectors, overwhelmed by solar glare, returned nothing but static frames of white noise, empty grids where once there were coordinates. Imagine staring into a spotlight. You know there is something behind it, a shape, a figure, yet the brilliance blinds you. That is what happened to our instruments. For nearly 4 Earth days, Atlas disappeared. The official explanation was technical telemetry. Dropout, cosmic ray interference, and overexposure during perihelion. Perfectly reasonable. But as the silence stretched, unease began to grow. Amateur astronomers scanning the edges of the sun reported faint signals, glints that shouldn't exist if the object were truly behind the glare. Data fragments from SOHO's LASCO C3 camera showed small pixel anomalies that moved too consistently to be noise. Could they be artifacts? Certainly. Could they also be evidence that Atlas was not where it was supposed to be? Possibly. Let's imagine ourselves in that observatory control room. The air smells faintly of ozone and metal. Monitors line the walls, each showing real-time solar data. Then one by one the feeds vanish. The images freeze, numbers flatten, and what remains is a clean silence. The data pipeline, the heartbeat of observation, stops. In those hours, the absence of information becomes its own kind of signal. Astronomers begin comparing timestamps. Each missing frame corresponds precisely to the window when Atlas was expected to reappear on the far side of the sun. It's as if the cosmos itself chose to dim the lights. We humans dislike gaps. Our minds rush to fill them. Some call it coincidence, some call it cover-up. Words like censorship and withholding start to appear in online threads. Others remind us that this happens every solar cycle, that the instruments simply blink, overwhelmed by light. But deep down, there's a more personal truth. We are not afraid of what we can't see. We're afraid of what we might see if the lights came back on. When the data resumed on the 5th day, Atlas had moved on fainter, colder beyond the corona. The images looked normal again, too normal, as though the gap had been erased. But a hole in time is not easily forgotten. The mind keeps tracing its edges, wondering what flickered inside. Perhaps nothing happened. Perhaps everything did. Every field of knowledge has its thresholds and those who guard them. In science, they are not soldiers or priests, but editors, reviewers, committees, and algorithms. They stand between raw discovery and collective truth. Their purpose is noble: to protect accuracy, to preserve order. Yet sometimes protection hardens into silence. After the conjunction blackout, a quiet unease began to ripple through the research community. Observatories reactivated their feeds, but no new frames of 3i Atlas appeared in the public databases. Inquiries to ESA, NASA, and NOAA Lab returned the same phrase data under calibration. Days passed. The calibration never ended. This was not unprecedented. A few years earlier, astrophysicist Beatrice Villarroel faced similar resistance. Her study on space fossils, clusters of transient objects appearing in old photographic plates, was rejected repeatedly from public archives. Her team had found 95 objects visible in 1950s sky surveys, but absent today unexplained by catalogued motion. The preprint server Archaic refused to host it, labeling it inappropriate subject matter. The data was peer-reviewed, the math clean, yet it vanished into the silence of moderation. And now some whisper history repeats. Imagine standing in front of a library where every book looks the same. The catalogue claims completeness, yet certain pages have been glued together. No one notices unless they try to turn them. That is how information can disappear, not by destruction, but by curation. Scientists defending the gatekeepers argue that skepticism is essential. If every anomaly were broadcast without context, confusion would drown understanding. They are right in part. But when skepticism becomes reflex, it no longer filters truth. It filters possibility. You and I can sense this tension. We see it in the difference between data and access, between knowing and being allowed to know. The instruments still record photons. What changes is the permission to interpret them. Some insiders whisper of internal circulars warning staff to avoid non-standard discussions of Atlas until a formal position is approved. Others deny it entirely. The truth, as always, may lie in between a mix of bureaucracy, fatigue, and fear. Fear not of discovery itself, but of what discovery might demand us to change. There is a term in cognitive science confirmation lock the state, where an institution reinforces its own worldview until alternatives become invisible. When confirmation lock meets cosmic mystery, you get the illusion of completeness, the feeling that all questions have been asked when in fact the deepest ones have only been deferred. Picture a data analyst sitting under fluorescent light at midnight. The latest solar images scroll past, clean static, harmless. She pauses on one frame, zooms in and notices a faint moving speck, one that shouldn't be there. She hesitates. She knows what happens to those who raise the wrong flag. Her cursor hovers over the delete key. Perhaps she saves the file, perhaps she doesn't. Either way, the frame disappears from public release, and the next morning the database looks perfect again. This is not conspiracy. It is caution multiplied by career. But when multiplied across thousands of cautious minds, caution becomes censorship. Science at its best is a dialogue with uncertainty. Yet the gatekeepers in guarding against error sometimes close the door on wonder itself. Beyond the gates, the stars are still there, unfiltered, unwatched, burning with the same light they have always had. The silence of missing data has passed, but in its wake comes something stranger, a surplus of light. The images return brighter, cleaner, almost too perfect. 3i Atlas has reappeared in the telescopes, but its clarity feels artificial, its sharpness uncanny, as if the universe were offering us a version of itself carefully edited for comfort. We like to believe that light tells the truth. It travels unaltered across space, carrying the memory of what was. But light, like language, can deceive through abundance. Too much brightness blinds just as effectively as darkness. In November, solar observatories released their first post-conjunction mosaics. Every pixel gleamed with precision. The sun's corona burned flawless white, the background scrubbed clean of interference. Yet when astrophysicists ran pattern analysis, the residual noise did not behave like noise at all. Faint oscillations repeated in perfect rhythm echoes that matched the earlier resonance cycles observed before Atlas vanished. If the data were authentic, it meant the interaction between Atlas and the Sun persisted even after separation. But official summaries mentioned none of it. Reports concluded with identical phrases, "No anomalous electromagnetic activity detected." We stand in that contradiction, a flood of brilliance that hides more than it reveals. Imagine standing on a snowy plain under a noonday sun. Everything around you glows, shadows disappear. In such radiance, even your own footprints fade. The landscape becomes pure reflection, and you lose sense of direction. That is what pure data can do, erase context through perfection. In philosophical terms, this is called the blinding of the witness, when information overwhelms perception, leaving us unable to distinguish signal from noise. In physics, it's simply saturation. Either way, the result is the same knowledge dissolves in its own light. A few independent researchers comparing unprocessed image sets noticed inconsistencies in brightness thresholds. Some frames contained residual overexposure shaped like a faint ellipse, a shadow of movement where no object should be. To an untrained eye, it was nothing. But to those who knew where to look, it was the ghost of Atlas present within absence, hidden within radiance. We might ask, why hide something? In light, darkness provokes curiosity, but brightness commands obedience. You don't question a glow that blinds, you turn away. Perhaps this is not manipulation, but nature's own defense. The cosmos, aware of our limited eyes, wraps its deepest structures in radiance so dense we mistake it for emptiness. The same principle governs stars. The hotter their core, the more opaque they become. The truth burns too fiercely to show itself. Think of photons as messengers, countless couriers crossing billions of kilometers to deliver the story of a single moment. Yet when too many arrive at once, the message blurs. Light that should reveal instead locks the truth inside itself, a radiant vault of information. You and I live surrounded by that same phenomenon. Our night sky is full of light older than life, yet we see only the visible fraction. The rest, infrared, ultraviolet, gamma, rushes past unseen, carrying stories we never learn to read. So perhaps the truth of Three-Eye Atlas is not hidden from us, but held within the brightness we cannot yet bear to decode. One day, when our instruments are stronger and our eyes more patient, we might look into that light again and finally see what it has been trying to tell us all along. When the last transmission ends, there is only stillness. The graphs flatten, the spectrographs stop humming, and the voice of the sun quiets to a low, invisible murmur. For the first time in months, the monitors glow with nothing but background light. The room feels strangely alive in its absence, the way a cathedral feels after the choir has gone. Silence in science is never empty. It is data, unmeasured signal beyond our reach. Every gap hums faintly with what might have been. You and I sit together in that hush, the hum of electronics faint behind us. The air seems heavier now, filled not with discovery but with reflection. Three-Eye Atlas is out there drifting away from the sun, already millions of kilometers from where it last shone. No longer bright, no longer in focus, just a thought sliding quietly through interplanetary night. We built equations to hold it, theories to contain it, archives to remember it. Yet the silence that follows is not defeat. It is the reminder that the cosmos does not owe us answers. It gives only echoes and trusts us to listen. Imagine leaning close to a seashell. You hear the sound of the ocean, but you know it's not the ocean itself. It's resonance, memory, air vibrating inside a spiral. In the same way, what we call silence is not absence, but transformation. It's the universe changing frequency, shifting beyond the bandwidth of our certainty. Somewhere data packets still travel particles of light, magnetic traces, whispers of plasma recorded in instruments that never sleep. But the human story pauses here. The gatekeepers close their logs, the telescopes cool, the analysts go home. And in that pause, the universe continues unbothered, radiant and immense. Perhaps this is what truth sounds like when spoken without words. No declaration, no revelation, only continuity. The philosopher once said that silence is not the opposite of sound, but its completion. In that sense, the silence following Atlas is not the end of its mystery, but its most honest form. It leaves space for awe to breathe, for humility to return. We will study it again when it comes back into reach, if it ever does. But for now, it drifts in the dark between stars, beyond hearing, beyond knowing. And here at the edge of its echo, we learn something that no dataset can record, that understanding does not always begin with a question. Sometimes it begins with a pause. The calendar marks late October, when the sky swells with a full bright supermoon, the moment when the moon drifts closest to Earth, its gravity pulling a little stronger, the tides rising a little higher. On nights like this, the planet itself seems to inhale. Far above the sun has just released its final coronal mass ejection, a gust of charged particles sweeping across millions of kilometers of space. Those particles will reach Earth in 2 days, brushing the magnetic field like wind touching a string. For a brief time, our world becomes an instrument. You can feel it if you listen closely. The magnetosphere flexes and sighs. Electric currents ripple through the ionosphere, creating subtle shifts in pressure that no storm on the surface can explain. Instruments at Kiruna Boulder and Nishio begin to spike K-index, climbing towards 7. Aurora curtains bloom farther south than they should, their light dancing where night was never meant to glow. Imagine standing beneath that sky. The moon above you burns pale and enormous. The air itself seems charged alive. In that moment, you're standing inside a living circuit. The moon pulls, the sun pushes, and the Earth responds with a slow planetary breath. Scientists describe this as geomagnetic coupling, the way solar wind compresses the magnetosphere, while lunar gravity tugs at Earth's upper atmosphere, synchronizing tiny oscillations between them. The effect is minuscule but constant, like two pendulums exchanging rhythm across emptiness. The Earth does not resist. It resonates. Some researchers have noticed that during supermoons, minor geomagnetic storms grow slightly more frequent. It is as if the moon, by coincidence or design, opens a window wider for the solar wind to enter. No violation of physics, only the reminder that forces we treat as separate often whisper to one another in invisible ways. Now, as the solar wind nears, sensors predict a storm that could bend magnetic lines deep toward the equator. Power grids will flicker, satellites will shudder in orbit. Yet amid that turbulence, something beautiful will happen. Auroras blooming across both hemispheres, painting the ion sky in green and violet arcs, a planetary heartbeat made visible. We are part of that rhythm too. Every cell in our bodies carries ions, each heartbeat shaped by electromagnetic balance. When the planet breathes, we breathe with it. The solar wind has arrived. Streams of ionized plasma brush against Earth's magnetic shell, wrapping the planet in invisible fire. For a while, everything hums, the auroras shimmer, radio waves bend, satellites stutter. Then as suddenly as it began, the noise fades. The instruments fall quiet, the graphs flatten. Scientists call this the recovery phase of a geomagnetic storm, when the planet exhales and the magnetic field settles back toward equilibrium. Yet in that hush, something curious happens. Beneath the crust far below the ocean, basins and mountain roots, faint tremors begin to stir. No alarms, no shaking walls, only the instruments notice. Seismographs at Santiago, Tokyo, Reykjavik register small but synchronized ripples, waves that do not belong to any known fault. They are not earthquakes, not yet. More like whispers in stone. Imagine standing on that threshold. You can't feel the movement, but you can sense it, a pressure beneath your feet, as if the planet were holding its breath. The sky above remains calm. Auroras still ripple at the poles, their light fading like embers. And in between those two worlds, the silent air above the restless rock below the Earth waits. There is a term for this seismo-electromagnetic coupling. It suggests that when the ionosphere vibrates under geomagnetic stress, tiny electric currents may flow downward through the crust, nudging faults already under strain. The effect is subtle, controversial, almost ghost-like, but measurable. Some studies note that the days following strong solar storms show a small uptick in quakes above magnitude 6. Correlation is not causation, but it whispers of connection. During this period, geophysicists speak of an earthquake drought, an eerie calm before motion. No major tremor for more than a week, a rare stillness for a living planet. But nature dislikes perfection. Energy always seeks release, and silence is often the sound of preparation. Picture the planet as a vast drum. Each solar flare, each lunar tug, each breath of the magnetosphere is a hand brushing across its skin. Most touches go unnoticed. But every so often one lingers, a resonance builds, and deep inside the mantle, pressure finds its rhythm again. We cannot predict which moment will break the silence. We can only observe the pattern, the pulse beneath the calm, and perhaps that is what makes it sacred, this fragile stillness that comes before motion, the invisible interval where the Earth listens to itself. When the tremor finally comes, whether next week or next century, it will not be violence but completion. The planet will exhale, the silence will end. There are nights when the world feels unnervingly still, when no wind moves, no machine hums, and the air seems charged with a quiet beyond sound. Those are the nights when the Earth's magnetic field breathes. You can't see it yet, it is everywhere. Invisible lines of force rise from the poles, looping outward like luminous threads, before falling back through oceans and continents. Every few seconds, those lines pulse, contracting and expanding, driven by the solar wind and by Earth's molten core. The pulse is faint, about 7.83 Hz, the same rhythm that some call the Schumann resonance. It is the planet's heartbeat humming just beneath awareness. Now imagine yourself lying on the ground, eyes closed. The soil beneath you vibrates with that frequency. Your body a lattice of ions, blood, nerves hums in reply. You're not separate from the field, you're woven into it. Each heartbeat, each neural spark synchronizes to the rhythm that has always been here. Scientists at Stanford HeartMath and ESA's swarm satellites have studied this subtle harmony. They find that fluctuations in geomagnetic activity mirror shifts in human physiology, heart rate variability, blood pressure, even mood. During strong magnetic storms, patterns in the brain's alpha waves waver, as though consciousness itself were listening to the sky. Some call it coincidence, others see resonance. When the magnetosphere trembles, the ions in our blood respond ever so slightly, adjusting like compass needles in miniature. Perhaps this is why ancient myths spoke of the Earth as a breathing being, not in metaphor but in sensation. On the surface, everything appears calm. Cities sleep, the sea rests, the air stills. But in the unseen, the field inhales again. The Parker Solar Probe reports a new wave of solar particles nearing the planet, a slow tide of charged breath that will soon ripple through the geomagnetic fabric. You and I will not feel it directly. Yet as the field flexes, our internal rhythms adjust, microcurrents in the skin, slight variations in thought, that sense of being momentarily unmoored and alert. The Earth is speaking in a language older than sound, the speech of frequency, the dialect of resonance. So tonight, when you lie beneath the quiet sky, know that you are within its breath. The same current that loops through the magnetosphere passes through you too. When the storms fade and the magnetosphere rests, something subtle lingers, not in the sky but within us. The silence after the solar wind feels different. The air carries a kind of clarity, as if the entire planet has exhaled. In that stillness, the Earth becomes a mirror, and through it we begin to see ourselves. For months we have watched 3i Atlas pass through the solar system, watched the sun answer with flares, and felt the planet tremble in reply. Every field, every frequency, every ripple of energy has mirrored a movement within consciousness itself. The universe, it seems, does not speak to us. It speaks through us. You might have felt it too, those moments when your thoughts quiet without reason, when a sense of vastness expands behind the eyes. It isn't imagination. The brain too is an electromagnetic system, a landscape of oscillations, each wave like a whisper of cosmic ancestry. Alpha, Theta, Delta. These are our personal constellations resonating with the geomagnetic field that cradles us all. When scientists measure this interplay, they call it field coherence, a subtle synchronization between the planet's magnetic pulse and the biofields of living beings. To them it's data, to poets it's communion. The distinction may not matter. What matters is that awareness itself seems to follow the same rhythm as the planet's breath. Imagine now that you're looking down at Earth from orbit. The auroras have dimmed, the continents glow faintly beneath a silvery supermoon. Around the planet swirls an invisible halo of magnetism, alive and silent. Within that halo, billions of minds dream, think, remember, each a small field vibrating inside a larger one. Every thought sends its own ripple into the collective magnetic sea. Some cancel, some amplify, some harmonize. In this way, the Earth is not only a physical body, but a resonant archive recording not words, but frequencies of emotion, intention, awareness. Perhaps that is why deep silence feels sacred. It's when the signal of self aligns perfectly with the pulse of the world. And in that alignment, reflection becomes revelation. We see that consciousness is not confined to the skull, but spread across air and soil, sky and field, one continuous thought dreaming itself into matter. The mirror does not show a face. It shows a vibration, one we share with stars, with comets, with the quiet traveller now far beyond the sun. The trajectory of 3i Atlas is now complete. It has passed perihelion, curved around the sun, and is sailing outward beyond the orbit of Jupiter, beyond the reach of most telescopes. What remains is not the light of the object itself, but a trail of questions. If you could trace its path across the sky, it would look deceptively simple, a slender arc drawn in quiet precision. Yet hidden within that curve lies a contradiction that no model has resolved. Every equation describing its motion works perfectly except when it doesn't. Its speed fits the numbers until the light curve shifts. Its brightness follows thermal decay until it brightens again. Atlas behaves both as a comet and not a comet, both natural and somehow deliberate. The scientists call this model tension, but to us it feels like poetry, the kind that hides truth in uncertainty. The cosmos, it seems, refuses to be reduced to a single narrative. Imagine unrolling a celestial map. The sun gleams at its center. The planets circle in neat geometry. Every orbit has a label, every mass a number. But along the outer edge, where data grows thin, the ink begins to blur. Here, the legends fail. Here, the lines of certainty dissolve into speculation. That border between knowledge and mystery is where Atlas lives. and perhaps where we live too. Physics gives us tools to measure but not to mean. It describes how, not why. Yet the longer we study the universe, the more those two questions intertwine. Every new discovery reshapes what we thought we knew, forcing us to redraw the map not because it was wrong, but because the territory has grown. In that sense, paradox is not the failure of science, but its compass. It points toward the edges, reminding us that every conclusion is temporary, every truth an approximation of something vaster. Think of gravity itself, once a law, now a curvature in space-time, soon perhaps a quantum echo. Think of light, both particle and wave, certainty and blur. Think of Atlas, both visitor and enigma, obeying laws while bending them just enough to remind us those laws are not absolute. You and I, standing beneath this quiet sky, are part of that same paradox. We are made of matter that resists collapse yet depends on it, of atoms that are mostly empty space yet solid enough to touch. To be human is to live within contradiction, finite beings longing for infinity observers inside the system they observe. So we draw the map again, knowing it will change. We mark the path of Atlas not as a line, but as a question. We plot our understanding as a constellation of maybes, and in that humility something extraordinary happens. The universe begins to feel alive again, not as a solved equation, but as an unfolding thought. Perhaps that was Atlas's message all along, not to show us a destination, but to remind us that even the most precise trajectory begins in uncertainty. Every paradox, after all, is just a new coordinate waiting to be explored. Now that 3i Atlas has faded beyond every telescope, we are left not with images, but with interpretations, two frames, that humanity turns to when the light is gone. Both claim truth, and both reveal only part of it. 1. The empirical frame. The discipline of measurement. In this first view, Atlas is entirely natural. Spectroscopic data from the Lowell Observatory and ESA's solar orbiter show volatile compounds escaping its surface carbon monoxide water, vapor trace silicates. Its acceleration near the Sun, though, unusual, aligns with models of non-gravitational outgassing, where sublimating ice acts like a weak jet. Its brightness spikes its tail reversal, even its strange polarization curve, all of them can be folded neatly into equations. To the empirical mind, the cosmos behaves. It does not decide. Atlas is a comet peculiar but obedient to physics. Every flare, every fluctuation finds a parameter to explain it. Temperature gradients, angular momentum, albedo shifts a catalogue of known causes for known effects. The story closes cleanly, its ending a number 68 kilometers per second outbound. And yet even here, something hums beneath the precision. Each dataset aligns perfectly until the next one doesn't. Each curve fits until it bends. The universe consents to being measured but never fully captured. Science endures because it accepts this, that knowledge is provisional, that the map is not the territory. Empiricism does not fail when mystery persists, it thrives on it. But mystery once seen refuses to be unseen. 2. The hypothetical frame. The architecture of possibility. Now step slightly aside. Suppose the anomalies are not noise but intention. Suppose Atlas is no ordinary comet but an engineered object, a probe travelling through interstellar space long before humans learned to name such things. It's not a fantasy, only an extension of probability. If life elsewhere is possible, then so is curiosity elsewhere. A civilization older than ours might send silent messengers, not broadcasting, only observing, powered by physics we do not yet understand. Under this frame, the 8 anomalies become features. The inverted dusttail is a radiation control mechanism. The unusual nickel to iron ratio suggests manufactured alloys. The outgassing patterns are corrections, not sublimations. Astrophysicist Avi Loeb has long argued that such possibilities deserve consideration, not dismissal. Not because they are proven, but because excluding them would contradict the very spirit of science, the willingness to question even what feels secure. Still, the hypothetical frame carries its own humility. The further it reaches toward wonder, the less proof it can grasp. Evidence becomes faint, fragile, a whisper among solar static. And perhaps that is fitting. If the universe ever wished to send a message, it would not shout. It would embed it quietly within the ordinary in a line of data, in a pattern mistaken for error. Between these two frames, the empirical and the hypothetical, lies the field where curiosity lives. We may never know which one is true. Perhaps both are in different languages. One explains the motion, the other the meaning. The comet has gone. The instruments rest. Yet the question it left behind continues to orbit us, silent gravitational, waiting to be observed again. And perhaps that is the point when certainty fades, wonder takes its rightful place. When every equation has been tested and every orbit modelled, one question still hums beneath the data, a question too soft for mathematics, yet too persistent for silence. What if the universe does not merely react but resonates? This is the resonance hypothesis, the idea that celestial bodies are not isolated systems obeying mechanical law, but instruments in a vast orchestra tuned by energy, frequency and field. In this view, 3i Atlas was not just moving through the solar system, it was playing it. As it passed through gradients of the sun's electromagnetic field, its charged coma interacted with solar plasma like a bow drawn across a string. Each flare, each coronal ripple became a note subtle, almost inaudible, but measurable in its rhythm. Physicists have already glimpsed the edges of this music. Data from the Parker Solar Probe shows plasma waves propagating along magnetic field lines, oscillating in phase with solar flares. The Schumann resonances on Earth pulse at 783 Hz, the same base frequency observed in atmospheric lightning and brain waves. Across scale and distance, the cosmos repeats itself in harmonic ratios. Under this hypothesis, Atlas was a temporary amplifier, a traveller that struck the chord between solar and terrestrial fields, linking them in one shared vibration. For a moment, our planet's magnetic envelope and the comet's plasma tail may have sung in unison. The result, a spike in geomagnetic activity, a shimmer of aurora, a shift in data patterns, and perhaps imperceptibly a shift within us. Skeptics will call it metaphor, and they are right to do so. No laboratory can yet prove that resonance guides motion. But consider how often the universe favours rhythm over randomness. Electrons orbit in quantized shells, discrete harmonics. Planets align in orbital resonances 3 to 2, 5 to 8 patterns, repeating across billions of miles. Even galaxies form in spirals as if rotation itself were a sound we have not yet learned to hear. If resonance is real, it is not supernatural. It is structure, the geometry of coherence beneath chaos. It means that every system from atom to star responds to vibration, and we made of the same material cannot be separate from that response. Imagine standing beneath the aurora on a clear polar night. Above you, curtains of ion light ripple in slow, silent waves. Beneath you, the ground hums with the same frequency carried through rock, water, and blood. Between the two, you a node in the pattern listening without ears. Perhaps that is the true discovery of Atlas, not proof of aliens or anomaly, but a reminder that observation itself creates harmony. When we look outward with curiosity, the universe answers in kind, and so the hypothesis remains: everything vibrates, everything connects, and every traveller, even a small shard of interstellar ice, may carry a tone that once heard changes the way the cosmos sounds forever. There comes a moment after every discovery when the noise fades and what remains is not certainty but quiet. The telescope's power down, the transmissions end. The object 3i Atlas has left the reach of our instruments, yet something still vibrates in the absence. That vibration is silence itself, not a void, but a frequency too low for hearing, too wide for thought. We think of silence as the end of resonance, but in physics the end of sound is not its disappearance, it is its amplitude reaching equilibrium. The wave still exists, stretched so far that its oscillation feels like stillness. The universe at its calmest is still singing. Imagine standing on the dark plateau of Mauna Kea after the last observation of Atlas. The sky's clean, vast, and almost painfully quiet. You can hear your own heartbeat, your breath echoing in your ears. That rhythm, slow and soft, matches the faint pulse of the planet's magnetic field, one breath every 10 seconds, one oscillation through the deep Earth currents. The Earth hums beneath you, and you realize silence is not the absence of sound, but the perfection of balance. In that equilibrium, every force meets its counterforce. Gravity holds, light escapes, motion pauses, the equations stop expanding and begin to breathe. It's here in the amplitude of stillness that understanding happens not as calculation but as recognition. For months we've watched data rise and fall, the surges of plasma, the flares, the electric storms. Now the values rest at zero, but meaning remains. The graphs are silent, yet the questions pulse beneath them. Perhaps knowledge itself is cyclical discovery, expands, wonder contracts, and silence becomes the midpoint where both exist together. Astronomers sometimes speak of the cosmic microwave background as the afterglow of creation. It is light stretched to stillness, energy slowed until it whispers. In that same way, the quiet after Atlas is its own echo, the residual hum of having witnessed something vast. You and I are part of that echo. Every neuron in your mind fires by electrical pulse, every emotion shifts your internal field. When you rest, when thought subsides, your body reaches its own amplitude of silence, where awareness holds but activity ceases. That is the biological mirror of the cosmic one. So we end where we began listening. Not for answers, but for alignment. Not for noise, but for presence. The amplitude of silence is infinite yet tender, and in its quiet rhythm everything, the stars, the atoms, the mind finally moves together. 3i Atlas is out there. Its light no longer registers on the sensors. Its orbit dissolves into the darkness where sunlight thins and memory begins. For months we followed its path, measuring, predicting, believing we could contain it with numbers. But every measurement ends the same way, with stillness. After motion, silence. After inquiry, awe. After light, the long breath of space itself. Imagine for a moment the last image. A point of brightness retreating beyond Jupiter's path, growing smaller until even the strongest telescope cannot find it. Nothing dramatic. No explosion, no farewell flare. Just a quiet vanishing like an idea leaving the mind. Yet what remains is not absence. It is resonance, the kind that hums inside after music stops. Every atom of that traveller once belonged to another star, and every atom of you once belonged to the same fire. We were never separate. We were never watching from outside. We were part of the same equation written in light. The scientists have turned off the instruments. Screens dim, graphs flatten, data flows into archives. And then comes that soundless pause when human breath becomes the only motion left in the room. That's when realization arrives, not as theory but as feeling. The understanding that curiosity and calm are the same act seen from two directions. One reaches outward, the other inward, both seeking balance. You can almost sense it now. The faint magnetic pull of Earth beneath your feet. The slow pulse of your blood syncing with the planet's hum. The invisible vibration of the sun's field stretching across 90 million miles to brush your skin. Everything that moves does so together. The stars are not distant. They are continuous with your heartbeat. Somewhere far beyond the heliopause, Atlas continues to drift. No longer reflecting sunlight, no longer glowing, yet still carrying the memory of motion. If you could see it, it would look like a grain of dust suspended in infinite dark. Still moving, still resonating. Perhaps it will wander for 1,000 years. Perhaps longer. Perhaps it will pass near another sun, another observer who will look up and ask the same questions we did. And in that way, it never really leaves the story. It only changes narrators. Silence in space is not emptiness. It is equilibrium. Every force balanced, every vibration stretched until it feels like stillness. That is the true amplitude of calm motion, so perfect it disappears. You can feel it if you listen. Close your eyes. Let your breath slow until it matches the rhythm of the planet's magnetic field, one cycle every 10 seconds like a tide of invisible air. Listen deeper below the sound of your own pulse. There it is, a faint hum, low and endless. That is not imagination. That is the universe breathing through you. All stories, even cosmic ones, end in the same way with listening. Because the point of science was never to answer everything, it was to hear the pattern beneath the noise. To realize that behind every orbit and every formula, something alive is waiting to be noticed. You are part of that noticing. The observer and the observed. The heartbeat and the horizon. The silence outside is mirrored inside. Two fields aligned, two breaths synchronized, two infinities touching. And so, as the night deepens and thought begins to drift, let go of the questions. Let go of the maps and measures. Let the hum of the cosmos carry you outward, past the stars, past the solar wind, past even the need to understand. There is no end, only stillness widening, only the sound beneath all sounds. The universe is not quiet because it is empty. It is quiet because it is complete. Breathe once more, and as you exhale, imagine it, Atlas still drifting slow and endless, its faint resonance folding into the dark, its memory echoing through the magnetic breath of Earth, its silence joining yours. Now there is only one voice left, a soft, infinite hum. It is the universe, and it is you.